Hi everyone, I am JULKA. In Inverse Trigonometry Part 5, today we will discuss some important questions of inverse trigo. Example 1. Solve for x where sin inverse x whole square plus cos inverse x whole square equals to 5 pi square by 8. We know that a square plus b square equals to a plus b whole square minus 2ab. So sin inverse x whole square plus cos inverse x whole square equals to sin inverse x plus cos inverse x whole square minus twice of sin inverse x into cos inverse x, which is equals to 5 pi square by 8. Sin inverse x plus cos inverse x equals to pi by 2. So cos inverse x equals to pi by 2 minus sin inverse x. After simplification, we will get minus pi sin inverse x plus twice of sin inverse x whole square equals to 5 pi square by 8 minus pi square by 4. Divided by 2 both sides, and we will get sin inverse x whole square minus pi by 2 sin inverse x equals to 3 pi square by 16. To make perfect square, adding pi square by 16 both sides. Left hand side is sin inverse x minus pi by 4 whole square, which equals to pi square by 4. Square root both sides, and we will get sin inverse x minus pi by 4 equals to plus minus pi by 2. First take positive sign and then take negative sign. In first case, x equal to sin pi by 2 plus pi by 4. Sin 90 plus theta is cos theta, and cos 45 is equals to 1 by root 2. In the next case, x equal to sin inverse minus pi by 2 plus pi by 4, which is equals to minus sin pi by 4. And the answer is minus 1 by root 2. Next example. If cos inverse x upon a plus cos inverse y by b equals to alpha, then prove that x square by a square minus 2xy upon ab into cos alpha plus y square by b square equals to sin square alpha. We know cos inverse x plus cos inverse y equals to cos inverse xy minus in root of 1 minus x square into in root of 1 minus y square. So we put this formula on the left hand side. This will equals to cos inverse xy upon ab minus the root of 1 minus x square by a square, the root of 1 minus y square by b square. Taking cos both sides, and we will get xy upon ab minus in the root of 1 minus x square by a square into a root of 1 minus y square b square equals to cos alpha. Xy upon ab minus cos alpha equals to in root of 1 minus x square by a square into the root of 1 minus y square by b square. Squaring both sides, and we will get x square y square upon a square b square minus 2xy upon ab multiplied by cos alpha plus cos square alpha, which equals to 1 minus x square by a square multiplied by 1 minus y square by b square. After simplification, we will get cancel x square y square upon a square b square from the both sides. After simplification, we will get x square by a square minus 2xy upon ab multiplied by cos alpha plus y square by b square equals to 1 minus cos square alpha, which equals to sin square alpha. Next example. If cos inverse x plus cos inverse y plus cos inverse z equals to pi, then prove that x square plus y square plus z square plus 2xyz equals to 1. Cos inverse x plus cos inverse y plus cos inverse z equals to pi. So cos inverse x plus cos inverse y equals to pi minus cos inverse z. We know the formula of cos inverse x plus cos inverse y, which equals to cos inverse xy minus the root of 1 minus x square into the root of 1 minus y square. And pi minus cos inverse z equals to cos inverse minus z. Taking cos both sides, and we will get xy minus the root of 1 minus x square and the root of 1 minus y square equals to minus z. And now xy plus z equals to the root of 1 minus x square into the root of 1 minus y square. Squaring both sides, and we will get x plus y plus z whole square is x square y square plus z square plus 2xyz, which equals to 1 minus x square into 1 minus y square. And after simplification, we will get x square y square plus z square plus 2xyz equals to 1 minus x square minus y square plus x square y square. Cancel x square y square from the both sides, and the answer is x square plus y square plus z square plus 2xyz equals to 1. Next example. If tan inverse x plus tan inverse y plus tan inverse z equals to pi by 2, then prove that xy plus yz plus zx equals to 1. It is given that tan inverse x plus tan inverse y plus tan inverse z equals to pi by 2. So tan inverse x plus tan inverse y equals to pi by 2 minus tan inverse z. Tan inverse x plus tan inverse y equals to tan inverse x plus y divided by 1 minus xy, which equals to pi by 2 minus tan inverse z. Taking tan both sides, and we will get x plus y divided by 1 minus xy equals to tan pi by 2 minus tan inverse z. We know that tan pi by 2 minus theta is cot theta. So tan pi by 2 minus tan inverse z equals to cot tan inverse z. And cot theta equals to 1 upon tan theta. So cot tan inverse z equals to 1 upon tan inverse z. After simplification, we will get xy upon 1 minus xy equals to 1 upon z. And after cross multiply, the answer is xy plus yz plus zx equals to 1. Next example. If sin inverse x plus sin inverse y plus sin inverse z equals to pi, then prove that x square minus y square minus z square plus 2yz in the root of 1 minus x square equal to 0. It is given that sin inverse x plus sin inverse y plus sin inverse z equals to pi. So sin inverse x plus sin inverse y equals to pi minus sin inverse z. In the left hand side, sin inverse x plus sin inverse y is sin inverse x in the root of 1 minus y square plus y in the root of 1 minus x square, which equals to pi minus sin inverse z. Taking sin both sides, and we will get x in the root of 1 minus y square plus y in the root of 1 minus x square equals to sin pi minus sin inverse z. Sin 180 minus theta is sin theta. So sin pi minus sin inverse z equals to sin inverse z, which equals to z. And y into the root of 1 minus x square minus z equals to minus x into root of 1 minus y square. Now squaring both sides, and we will get y square into 1 minus x square plus z square minus twice of yz into in the root of 1 minus x square, which is equals to x square in bracket 1 minus y square. After simplification, we will get y square minus x square y square plus z square minus 2yz into the root of 1 minus x square equals to x square minus x square y square. X square y square cancelled on the both sides, and the answer is x square minus y square minus z square plus 2yz into the root of 1 minus x square equals to 0. Last example. Prove that tan pi by 4 plus half of cos inverse a by b plus tan pi by 4 minus half of cos inverse a by b equals to 2b by a. Let half of cos inverse a by b equals to theta. So cos inverse a by b equals to 2 theta and cos 2 theta equals to a by b. Now take left hand side. In the left hand side, replace half cos inverse a by b by theta. So left hand side is tan pi by 4 plus theta plus tan pi by 4 minus theta. Put the formula of tan a plus b and tan a minus b, and after simplification we will get in denominator 1 minus tan square theta. In the numerator we will get 1 plus tan square theta plus 2 tan theta plus 1 plus tan square theta minus 2 tan theta. 2 tan theta is cancelled by minus 2 tan theta, and now we have 2 1 plus tan square theta divided by 1 minus tan square theta. Divide numerator and denominator both by 1 plus tan square theta and we will get 2 divided by 1 minus tan square theta divided by 1 plus tan square theta, which is the formula of cos 2 theta. And now put the value of cos 2 theta, which is a by b. So the answer is 2b upon a, and that's equals to right hand side.